Okay, can you see my screen?
Yes, we can.
Okay, so we're going to go through all these slides as we did before Christmas. Before anything else, I would like to emphasize those points. First, you need to check your exam timetables. It's an individual, so it should appear on your personal timetables. I can show you what on my side I can say currently. Looks like this. Yeah, so it will be on Thursday, the 11th, next week, okay, 10 to 12 o'clock. So most of you will be in the active sports hall. For DDS students, you will have a separate room for the exam. So you basically have 30 more minutes in the exam. So I will be in the exam for invigilation, and also there's some support invigilators who the university has recruited some of them. I suppose we would have 5 or 6 people on site. So my responsibility for the invigilation would be answering any questions if you have about the exam paper. So maybe you have spot something maybe not right or whatever. So you can ask me about that. And the invigilators from outside, normally they wouldn't answer you any questions. They just monitor your exam, then to just stop if someone wants to talk to anyone else, to each other. So that's what they're going to do. And at the end, they're going to collect the papers back. Then you will be told you can leave the exam room. Okay, so that's what will be happening on the day for the exam. Okay. Stop my camera. Okay, so that's for the exam. And one thing I would like to remind you, please come on site on time. So ideally 15 minutes before the exam starts. If you're late, you wouldn't be allowed to immediately enter into the exam room. You would have to wait for, I think, some 20 minutes. You basically cannot do anything after that 20 minutes or 30 minutes, okay? So that means if you're late, you're going to lose 30 minutes for the exam. Okay, so it's very important for you to be on site on time. And you don't have to take anything with you rather than your ID card, then pencils or just some pens with you. You don't need to use any calculators. Yeah, you need to switch off your mobile phones. Yeah, just like that. So these basic requirements or disciplines in the exam. Okay, so that's quite important. And the coursework marking is still on the way. So I think it will be available Monday next week. Okay. So the feedback and the marks will be available on the Moodle side. Then you can have a look. If something you think may not correct or something we have missed at some points, you can just come back to me too, so we can have another look. Okay, so all these marks are provisional. It's still subject to moderation. Okay, internally, me and George will do some internal moderation. And afterwards, all these marks will be presented to the exam board in February. And after that, it basically will become official. Okay, so before that time, normally it's still provisional. Okay? Once you have received your marks, I would suggest you to really do some simple calculation in terms of how many marks you would need or to achieve in the exam, okay, in order to be distinction for this module or in order to pass this module. So you basically need to do some calculations. Normally, if you have a mark more than 40, more than 50, okay, 48.5 or 50, then in the exam, you would only need to have 30 marks to pass this module. And of course, if you want to be distinction, then if your coursework marks less 65, then you would need to have something nearly 80 marks in the exam in order to be overall distinct in this module. Okay, so you just do some simple calculation. At least you need to make sure you can pass this module. Okay. What would be the most uncomfortable situation would be you have a coursework marks less than 40, but more than 30. Okay, so in that case, you need to make sure in the exam you need to have marks, some marks for like more than 50 in order to pass this module. Okay, if in the exam you still have a mark between 30 and 40, then you would need to do receipt for both the coursework and the exam. Okay, so that's what basically you need to know. For referral coursework, we still have some students who didn't submit their coursework even after that 5 actual working days. So I'm going to email whoever hasn't submitted their coursework to clarify with them about their circumstances. So if there's no reason, you just simply didn't do it, then you didn't submit it, your coursework, then in over Easter holidays time, so it will be in around end of March or early April, you need to submit your receipt coursework. Okay, if you had some reason, so you applied for deferral, then you need to submit your coursework again in the same time as deferral coursework, but the marks will not be kept. Okay, so this is what you need to do relating to your coursework. And the deferral coursework will have a different data set. So you don't need to continue with what you have done if you did anything already. So you would have to restart with a new data set. Okay, even you have applied for deferral. Okay? So this is some important information I would like to emphasize to you. In terms of revision, we still have more than a week's time available. So if that is needed, I'm happy to organize another time next week, maybe Monday or Tuesday. So we can have another session, just a pop-in session online. If you have any questions, you can just come in to ask. Also, you can just try last year's exam papers, last 2 years exam papers, then I would like you to write down your answers. And if something is not clear to you, you can just come in to have discussion or send your answer to me so I can have a look. Okay? That's very important for you to really try the papers by yourself. Not only just come here to just say, oh, what are we going to discuss? What are the answers? That may not be really helpful. You have to have your personal experience. You just really go through all these questions and really write down your answers. Okay? That's very important. And for these slides, for all these slides, I would like you can just go them. This is the basic checklist for the revision. So you can go through all these points by yourself. They basically cover everything we have talked for this module in the last 11 weeks. Okay, so this is week 12. So in the last 11 weeks, what we talked, it's actually quite comprehensive. What I would like you to just pay more attention to is some points they're highlighted like in red. Okay, for example, date and date types. Unfortunately, yeah, I have seen in some coursework submissions that some date types are still not correct. Okay, so this is very important. Date types. We basically talked about 4 types of data, but mainly you only need to be make a difference between 2 major types. One is categorical, another one is numerical. Categorical basically means symbols, categories, classes, groups, right? So their values may appear in numbers, but those numbers are not real numbers which we can do any calculations with. Numerical calculations, okay? Only some logical operations are meaningful. Okay? Another major type is numerical, which means they are real numbers, so we can really do calculations with them. And so you basically, at least these 2 major types, you should be able to make a difference between them. Okay. Here you can say change data types. Okay, so numerical to categorical, categorical to numerical, for various reasons. Yeah. And the data quality problems, missing values, outliers, imbalanced classes, noisy, random errors, and so on. Actually, in the coursework, some students that their submissions were very attractive. Yes, they're really excellent. They had some very detailed discussion regarding all these major data quality issues. Okay. So that's actually very good. Some of the submissions, as far as I can see. And this is about some calculations, measures for models' performance. And so they're related to some calculations. And those calculations like accuracy, error rate, to positive rate, to negative or whatever rate. So you should be able to calculate them. Ideally, you need to remember the formulas, okay? Which formulas you're going to, you need to apply.
Sorry,
And
sir, you said we're not allowed calculator, but like,
you can leave them as fractions. Say if it's 3/4, just leave it as 3/4. That's fine, okay? You don't have to give some really decimal numbers. You can leave your answers as fractions, okay? Calculator of support, confidence, and lift. So they're related to either item sets or a association rule. Okay, X to Y, Y to X. So what is support? What is confidence? What is the lift value of that rule set? Okay, so this is just some very simple calculations, but you need to really remember them also be very familiar with them. So therefore you can do your calculations very quickly. And this is about cluster algorithm. Mainly it's about the k-means algorithm. I have seen some very good work in the submissions. Students use the different ways to interpret the results from the k-means. Yeah, that was very impressive. Okay, so very good. Someone used the nested pie chart, someone used the bar chart, someone used the statistics. So it's really good. So this is about what are the major issues related to the k-means algorithm. Okay, very sensitive to outliers, very sensitive, very different value ranges. Okay, only applicable for numerical data. So therefore, if any attributes, variables, they are not a numerical type, we have to convert them into numbers by using one-hot encoding. Okay, so which in some submissions actually you have done. So the relevant pre-processing. Okay, so change the data type if some attributes that are not a numerical type. Reject any ID type attributes. So like in your coursework, you wouldn't use incident ID number for whatever analysis. Okay? Missing values, outliers. So all these some common data quality issues. So you need to be aware of about them. Association rule analysis. So we talked about the a priori algorithm. A priori algorithm. So we talked about minimum support threshold and confidence threshold. So here you need to be just talk about how to determine a proper minimum support threshold. So we talked about different ways to do it. Decision tree induction. So this is we talked about basically mainly entropy-based algorithm. Quite a few of you use the Gini-based criterion for decision tree induction. So that is fine. Okay, because we have different criteria available. Okay, and decision tree interpretation. So if you have decision tree, how you can write down the corresponding decision rules from that decision tree. Okay, because each tree represents a set of decision rules. So you should be able to, once you have decision tree, you should be able to write down the relevant decision rules. Regression, there's nothing special. Okay, so those points in red, I would like you just to pay more attention. And also at the end of all these slides, I have added some important like formulas or some concepts and you should be very familiar with. So this is the formula for calculating support, okay, and confidence. So you need to be familiar with them. This is about the calculation for lift, okay, and what the value of lift indicates. Okay, if it's equals to 1, basically that means the item sets X and Y are independent on each other. If greater than 1, if it's greater than 1, that's positive correlated. Otherwise, less than 1 is negative correlated. This is about how to determine the proper minimum support threshold. Okay. So basically, we need to use trial and error process, which means we need to try multiple values for the threshold. Okay, not only just choose one threshold, we can try different values for this threshold. So if the pattern we are looking for is very often, so appeared quite often, then normally we would have a higher threshold, minimum threshold. Otherwise, we would have so many frequent item sets, which we need to combine them to form different rules, then check their confidence values. Okay, so that will be more time consuming for us. So on the other hand, if the pattern we're looking for is very rare, which means they didn't appear many times, okay, just only a few times, then our threshold should be very low. Okay, otherwise we wouldn't be able to detect those rare patterns or rare item sets. Okay, so there's just basically some principles. Another one is as a guidance, we can use the support count of every one item set in our data set as a reference. Because we know the property, the anti-monotone property of support, then for if we were looking, say we have item sets A and B appears a few times than B. Okay, A appears a few times than B. Then if we want to find out any rules containing item set A, then the support has to be below whatever times that item A has appeared. Okay, if the support threshold is then higher than actually how many times it appeared, item set A appeared, then we wouldn't able to detect any rules or any item sets containing A. Okay, so this is what it says. And normally, once we have a transactional data set, we can immediately find support count for every one item set. It's basically every distinct item set. Okay, like a diaper, beer, banana, and so on. So how many times each of them appeared? So we can always use that as a reference when we want to determine the minimum support threshold. So this is about support threshold. Next one is about confusion matrix. So you need to be familiar with this layout for the confusion matrix. So basically, on the first column in this matrix, we have what we called observed classes. And we just consider just two classes case. So any testing sample can only come either from yes class or positive class, or from no class or negative class. Okay, so that's because we only consider two classes classification. Okay, so here is what we have observed for each of the testing samples. Okay, if I have 50, then we know for each of those 50 samples from which class it comes from. Okay, so either yes class, positive, or no class, negative. And these two columns, or this row, the first row is related to what has been predicted by our classifier. Okay, because for each testing sample, our classifier can only have one of the two outcomes. So one outcome is yes class, another outcome is no class. So it can only be one of them. Okay, one of them. So normally I would like you to just follow this layout if you're required to draw a or create a confusion matrix. Okay, so make your confusion matrix clearly labeled in terms of what each row means, what each column means. Okay, so basically yes, no, and these are predicted. Those are observed. Okay, then for two classes case, we have just four elements. Okay, true positive, true negative, So they represent if a sample comes from yes class and has been classified as yes, then we have a true positive. If a sample comes from no class and has been classified as no, then we got just one true negative. Okay, so those two elements, true positive and true negative, they are related to correct predictions or classifications made by our classifier. Okay. The other two elements, false negative and false positive, they are related to mistakes. Okay, false negative means a testing sample comes from a positive class, but has been classified as negative. So therefore, that negative is not true. It's a mistake. So therefore, it's called false negative. Okay, so this figure, false negative. So similarly, if a testing sample comes from negative class and has been classified incorrectly as positive, then that positive is a mistake. It's not true. Therefore, we have a false positive. So you need to make your confusion matrix clearly labeled. Not only just just put just the four. You got four numbers here, but there's no any labels regarding what each number actually indicates. So in that case, you may lose some significant marks. Okay, um, so this is what I would like to emphasize. So this is about calculating accuracy and error rate. Okay, error rate. So you can represent them in terms of true positive, true negative, false positive, false negative. Okay, when you add them together, they should make 100%. Some other calculations related to sensitivity, specificity, and precision. Okay, so all this, you just need to be familiar with them. Okay. They're always related to the four elements in a confusion matrix: true positive, true negative, false positive, and false negative. This is, I think, the very last slide. So I would like to emphasize, when you create your confusion matrix, you actually can do some self-check. So when you add all these four numbers together, so I got four numbers here, then they should equal to the total number of testing samples we have used for model evaluation. Okay. So because for any testing sample, they basically would go to one of those four elements. Okay, four elements. So therefore, when you add all of them together, they should make the total number of testing samples. Okay, so if you have 100 testing samples, then when you have created your confusion matrix, then you can add all these four numbers together to say if really they make 100. If not, something has gone wrong. So you need to have double check. Okay, so this is about total. And if you add the two elements along the first row, like this yes class, then they should equal to the total number of testing samples from yes class. Okay, so therefore, if all these testing samples from yes class have been classified correctly, so we have 100% true positive rate, then we would have 0% false negative rate, because all these positive samples have been classified correctly by our classifier. Okay, so this means when you add these two figures together, true positive, false negative, they should equal to the total number of samples, testing samples, coming from yes class. So if they don't match, then something again is not right. So you can have a double check. Okay, so similar for this second row, no class related to no samples from no class. When you add these two figures together, they should equal to the total number of testing samples from negative class from no class. Okay, so therefore, if every sample from no class has been classified correctly, we would have 100% true negative rate. And therefore, we would have 0% false positive rate. Okay, so just add these two figures together to say if they match the value you have, the number of samples from no class. So you can do some self-check. Okay? So this is important. If you are required to create a computer matrix, then you should be able to label all these columns, rows clearly. Okay? Then make sure you're able to actually double check, do some self-check about if the figures you have entered into the matrix are correct or not. Okay? So those are some slides, and especially the last a few slides, they're very important. So it relates to important concepts and the calculations. So you can just always refer to those slides when you do your preparation for the exam. Okay. So what else you would like me to do?
Hello, sir. How are you?
Yeah, I'm fine. Happy New Year.
Happy New Year. Yeah. Thank you. So basically, could we please go through exercise number 4? I know we've done, but could we go through exercise number 4 again on the second, on the last past exam paper, please? Is that possible?
Exam paper.
Yeah.
Before last year's or last year's?
The last one.
So 2020, 2022, 23.
Yeah, I believe so. Yeah.
This one.
Yeah, it's the number 4.
Yeah,
I'm
this
sorry.
is number 4.
I'm sorry. No, it's not this one. It's the other one. Apologies. It's basically the two classes.
Okay,
the
this
graph.
one. Yeah.
Yeah, this one. That's right.
Okay.
Thanks.
Okay, let me make this bigger. Right. So this is about a classifier. Okay, classifier is basically decision tree, and is for two classes classifications, right? Yes class, no class. So here they say zero class, class 0 or class 1. Okay, and you can determine which class is your positive class or negative class. It doesn't matter. Just the two classes. And what we are required to do here is what is the entropy value of this testing dataset. So if you look at this testing dataset, it basically has 6 samples. Okay, 3 from each class. So we got 3 black points and 3 white points. Okay, so basically we have an equal number of samples from 2 classes. So therefore here it asks you about what would be the entropy value of this dataset. Okay. So you can use the basic concept, not necessarily using the formula. If you remember the basic concept for entropy. Okay. So entropy takes maximum value when we have the most uncertain case, because entropy indicates uncertainty in terms of samples class labels. Okay, so for 50 to 50 case, we have the most uncertain case. Okay, so therefore entropy takes the maximum value. In this case, for two classes case, the maximum value is 1. Okay, so the answer for this is 1. But here it asks you just show how you get your answer. Okay, so then you basically need to mention some equal number of samples from two classes. So therefore, entropy takes maximum value. And for two classes case, the maximum value of entropy is 1. Okay, so that's the answer. Okay. Then if we come back to here, the decision tree now, we don't have the tree, the structure of the tree. Instead, we only have those rules represented by the tree. Okay, so you can see here, if x is greater than 1 and not less than 1 and not more than 2. Okay, so for x in this area, then the sample would be classified as 0 class, okay, from class 0. Otherwise, if it's beyond these two boundaries, okay, either below 1 or greater than 2, it will be classified as class 1. So that's what this rule set says. Okay. So if you link those rules to this diagram, because x and y, they indicate coordinates, okay, coordinates for your samples, okay, for your samples. And in this case, the decision boundaries, they're not relevant. Decision rules, they're not related to whatever the values for y. Is only related to the values for x coordinates, okay? So you can literally think about, if you draw a line from this point, say point 1, just parallel to y. Okay, if you draw a line here, and that actually indicates the lower boundary, okay, lower boundary. And similarly, you can just draw another line starting from this point 2, parallel to y. You would have another decision boundary or up boundary for this area. Okay, so for any samples inside this area, it will be classified as class 0. Otherwise, it will be classified as class 1. Okay, so this is how you can use those conditions. Okay, so they're linked to decision boundaries. So one boundary is x equals to 1. Okay, another boundary is x equals to 2. Okay, then now you can say which samples have been classified correctly or incorrectly. So we have 6 samples, and we know that this boundary is one is x equals to 1, another one is x equals to 2. Okay. Yeah. So which of those 6 samples have been classified correctly? Okay, so you basically draw. So sorry, my hands are shaking, so I cannot draw a very straight line. I do apologize for that. So it's basically a straight line. It's not any curve. Okay. Yep. So inside here, this is a class 0. Okay. Area, and here is 1, and here is 1. Okay. So now you tell me. I don't know who asked this question. Okay, can you just tell me, for those 6 testing samples, which one has been classified correctly?
Yeah. So
Which
it's basically the middle one is correct. It's true positive. The 2 ones. I cannot draw, unfortunately. Yeah, the 2 white ones in the middle, they're correct. The only incorrect is the left one, the bottom left.
Yeah. Good. So this is once you have understood this, okay, so then you can move to, let's just skip the question B, just look at this C, okay, confusion matrix. So now we just based on what you just said to create our confusion matrix. Sorry, this may take you some more time. So again, here is observed. Okay, this column observed. So let's say class 0, class 1. And here is predicted. So class 0, class 1. Okay. So this is our true positive. Okay, true positive in terms of class 0. Okay, what is the value for true positive? Class 0. 2.
True positive. Okay. It's 2, right? Yeah.
2, yeah. So this is false negative. Yeah. So what is value here? What is value here?
This is either 0 or 1.
What is value for false negative?
I would say is 0 or 1.
No, you tell me.
Okay. So I'm not sure the bottom left if it goes here or as a.
Okay. How many mistakes our model has made?
Only 1. Yeah.
For samples from positive and classified as negative. How many of that?
Just 1.
Yeah. So then just 1. Okay. So we have 3 samples from class 0. 2 of them have been classified correctly. So therefore, we have true positive equals to 2. Then 1 mistake. So this 1 mistake is here. Yeah. This is 1 mistake. And when I add these 2 together, they make 3. They make the total number of samples from positive class. Then let's look at true negative. So what is the figure for true negative?
Yeah, it's 2 and the other one is 0. I'm sorry, it's 3 and the other one is 0, right? Can you hear me? I'm not sure. I think your network is not, your connection is not good. Hello?
I think your connection is not stable.
Okay, if you look at this 14 marks, 14 marks is like so we have 4 elements. So each element is 3 marks. That makes 12. Then 2 marks for your layout. Okay. I got a loss. That connection. No.
Yeah, can you please go over it again because we couldn't hear it.
Yeah, now we can hear you.
No one can hear me.
Now we can hear you. Now it's good. Now it's good.
Now it's good. Okay. So let's go back to where is that? So from which point you didn't catch what I said?
I think it's the last 2 ones, the true negative, false positive, the 3 0.
Okay. So false true positive, false negative, that part is right. Yeah, is okay.
Yeah.
So just let's look at for true negative and false positive. True negative so they're related to class 1. So have class 1. Class 1, they are those 2 points and that point. So all of them are correctly classified. So therefore, true negative is 3. The value is 3. And here is automatically 0 because we have 3 samples from negative class, from class 1. Okay, so if every sample has been classified correctly, then we wouldn't have any false positive here. So it basically takes value 0. Okay. Yeah, so for this question, basically you need to first work out the decent boundary. You need to map those conditions into this diagram. Okay, so those are decent boundaries. They're straight line, or not like here, it's a curve, sorry. And inside of these 2 boundaries, class 0, outside class 1, class 1. Right? Then you can clearly say which samples have been classified correctly or incorrectly. So like these 2 samples, yeah, 0 area, correct. This is incorrect. Okay, and this linked to false negative. And all the samples from class 1, these 2 and that one have been classified correctly. So therefore, we have true negative value 3. Okay, and you can decide which one would be your positive class or negative class. Okay, so it's up to you. Just if you just label them clearly, then you say class 0 is your positive class. Okay, then that's fine. Class 1, therefore, automatically will be your negative class. You can swap them, it doesn't matter, but you need to be consistent. Just in other books, you may say different layouts. That's fine, as long as you clearly, you have clearly labeled them.
Yeah.
Yeah, okay, so that's fine. Don't just say you have no any labels here. You just simply, even there's no, suppose you put true negative, or even know this, you just give me like those 4 numbers, 2, 1, 0, 3. It's basically meaningless because you didn't give a context. So all these labels give us the context. So those numbers will be meaningful. Otherwise, yeah, yeah, you would lose some marks.
Can it be if it's over 2 classes? I believe it's not going to be the case, but how do we work on that?
More than 2 classes.
Yeah.
Okay, then that's fine. You suppose you have in your coursework, many of you actually considered more than 2 classes. So if I have 3 classes, 0, 1, and 2, so they're categorical. Okay, they're not real numbers. They're just the indicate. So therefore, the matrix would be 3 by 3. The matrix you have would be 3 by 3. So can I do this? Okay. So there's 1, 0, there's 1, there's 2, and there's 0, 1, 2. So this side is observed, and this side is predicted. Okay, predicted. Then here, true positive. Here is actually 0 to 0 positive. Okay. Then 0 to 1. This is false, false 1, false 2. Okay, so you can only indicate it like that. So this is true positive for class 1. This is true positive for class 2. You can just interpret it like that. So this is 0 to 0, true. And this is 1 to 1, true. And this is 2 to 2, true. Okay, for any other elements, there are mistakes. So this one is false. 1. Okay, this is force 2. Yeah, here is a force. Yeah, there's a force, and this should be, yeah, force 1, force 2, and this force 1, force 2. Yeah, the same. You can just label them like that. Okay, they basically indicate mistakes. Right? But normally we can say just the 2 classes, classification cases.
Okay, thank you.
So if you're able to do this true positive, true negative, you should be able to answer this. What is the rate? And again, here you need to refer to the formulas. Okay, formulas. What is a true positive rate, a true negative rate, or false positive rate, or false negative rate? Okay. So from the slides, you can say all the formulas. Then here, false negative rate is like this. False positive rate is this. Okay. Then this is a sensitivity is true positive. So all these formulas are there. But if you don't remember them, then there's no way for you to. And of course, you can base the definition to work out the formula. Yeah, so those formulas, that's why I put them here, just to make, yeah, it's more convenient for you to have a look. Then binary decision tree, and how to create this decision tree. You can do it in 2 ways. One way is like this. So root node, then immediately leave terminals. Okay. So class 0, class 1. Okay. So what you could put here would be this. So you can put them into here. Okay. So if this is satisfied, so if this is yes, so this branch is related to the yes, so then class 0. So this is for no. Then it basically means beyond, outside this area, then it will be class 1. Yeah, just this is the binary decision tree. So this is one way to do it, not very typical. The typical decision tree for each node, normally we would have only one condition inside. But here, as you can see, we have actually 2 conditions. Right? So therefore, you can break this down if you like. Okay, this is okay. If you do it like this, it's okay. Okay, but if you look at for some typical case, you would do something like this. So if x less than 1, x less than 1. Okay, let me off. Make it bigger. So x less than 1. Okay, so x less than 1. So we have yes and no. So if this is yes, what you would put here? If like x less than 1 is a yes, so what you put here? It will be a child node or a terminal, a leaf node. Yeah, what would you put there? If x less than
Yeah.
1 is a yes, okay?
Yeah, that's class 1.
Then class 1, good. So this would immediately leads to a terminal, which is class 1, yeah? What about this branch?
This is gonna be another decision tree.
Another
which is gonna be-
condition. Yeah, we need to apply another condition, okay? So could to put x less than 2. Again, yes or no. Okay, so what to, we have no any other conditions. Yeah, what to put here?
I think you will have first of all to do equal or less than 2, and
Yeah, we could do it like that. Yeah,
and
that's
the
fine. Okay.
the yes is 1. I'm sorry, the yes is 0, and the other one is 1.
So yes is what is 0. Yeah.
Yeah, that's right.
So here is 0. And here it would be 1. Yeah. So that's that.
Okay.
You either do it like this. This is more typical, okay? Because each node has only one condition applied. But you could also do it just like this. It's fine. Just you apply all this into that. Yeah, then that's fine. But you need to be aware. Typically, we would do it like that. Okay, just each time only testify one condition. Okay, so x less than 1 or x less than 2. And if you change this to, let's say, greater than 2, what would you change here? Still here, yes, no. What would you change here?
Yeah, if it's over than 2, then is
Yeah,
class
swap
1.
them. Yeah, swap them. So this time, this is 1 and this is 0. Okay, so if you're clear, it doesn't matter what condition you put there, which one is yes, which one is no, greater than, less than, it doesn't matter to you. So if you're clear about this, yeah, so this is related to 4B. Yeah, just draw the binary decision tree. So here, there are decision rules related to that decision tree. And it asks you to give the corresponding decision tree. Okay, just you can just draw it like this, right? So this is basically for question 4 from before last year's paper. 35 marks. So this basically is 1, okay, because 50 to 50. 50 to 50, 2 classes, and then entropy value is 1. Right, so different boundary, then here you need to basically work out to positive, to negative, all this. Right? Then if those things are correct, if you remember the formula, then you can calculate the rate, okay, a rate. Not only the true positive, it's a rate. So it's important for you to give formulas, because if you had made a mistake here, and it could be carried on to this. So if you don't give me formula, I wouldn't be able to tell you actually have understood this or not. So it's better for you to give the formulas, and when you take some numbers from here to your formula, then if any numbers here, they're not correct, then of course your answers for those 2 rates may not correct, but you would be still given some marks because the formulas are correct. Just the mistakes actually came from here. So you wouldn't be double just punished for the mistake. Okay, so it's important for you to give the formula, not only just give the final answer. It's basically hard. Sometimes it's hard for me to tell which part you have understood or you did correctly. Okay, so that's important. You need to clearly show how you get your answer. Just give some formulas. This rate, you can leave it as just, yeah, something like this. Yeah. Whatever. You don't need to really give decimal values. You can leave it as fractions. Okay. Yeah, so this is for question 4. For question 3.
See, I have a question for the one that we just did.
Sorry, can you repeat that?
I said I have a question for the question 4A.
Okay, what's your question?
Yeah, so assume the classes were not the same. So maybe class 0 was 4 and then class 1 was 3. How would you calculate the entropy value?
It doesn't matter. It's just a label for classes. So class 0, class 1. Or you can say class A, class B. It doesn't matter. It's always 2 classes. Yeah.
Yeah. So what would have been the value? So for this one, the value was 1 because I think they were both 3.
Okay. Let me show you the slides. Okay. I didn't include that slides in the revision slides. Okay. But I can just quickly go to that slide. That was in week 7, I think. Yeah. No, it's week 6. Okay, so this is basically the formula.
So to calculate this, we would need the calculator, and you said we're
You
not
don't need to
allowed the.
calculate. This is a constant for 2 classes case. The entropy value of given this set is between 0 and 1. The maximum is 1. And in this case, it's 50 to 50. So therefore, it takes the maximum value. Yeah.
Yeah, so my question is, what if it's not 50 to 50? So say it's like 40 to 60 or something. What would the answer?
No. In this case, it's 3 to 3. We have 6 samples. Yeah.
Yeah. So what if we don't have 6 samples? So what if you have like
Okay, that's a
11
good
samples or
question.
something?
That's a good question. If that really appears, you wouldn't need to have calculators. Or you will be given a table for you to look up what the values. Okay, like a 2 to 3 or 1 to 3, whatever. Yeah, but only for this special case, 50 to 50, the value is very specific, and you wouldn't need to do any calculation. You can only just apply the concept. Yeah. I understand. Say if we have 6 samples, okay, then 2 from 0 class, okay, 0 class, and 4 from class 1. In this case, we have to use calculators. Oh, we have a log function table to look up what actually the values. Okay, yeah. But for this particular case, we wouldn't need that because the concept is very clear. It's just 50 to 50, most uncertain, then entropy takes the maximum value. In this case, for 2 class case, is 1. If you look at the formula here, yeah, if you look at this log C C is the total number of classes. So if you substitute C with 2, then the value is 1. This is a, yeah, if you want to use this formula, that's what it basically says. So log 2 is equals to log 2 based on 2 is gives value 1. So that will be the answer. For 2 classes case, is basically between this. The value range is this. For entropy, the maximum value is 1. So in this case, you only need to apply the concepts, not necessarily you use the formula. Right? But if, as you asked, if we have other cases not equal number of samples from class 2 classes, then yeah, we would need to use some formula or just calculators or just log tables to get the values. Okay, any other questions?
I just want to make sure, is the question number 4C on the table top left that we made together, the matrix, can you scroll up a bit to the table if it's possible? Yeah. Can you explain why is Fn equals to 1 and Fp equals to 0 and not other way around?
What is your view? If it's not 2, what other values would you suggest? So the condition here is we assume class 0 is our positive class, okay? Class 1 is our negative class. Of course, you can do it another way around. But here, the condition we have made here is class 0. Class 0 here is our positive class, okay, positive. And class 1 is our negative class, or no class, right? So therefore, here is positive class 0, negative class 1. So therefore, this entry is related to positive to positive, and is true positive. Okay? So if you say there shouldn't be 2, what other values would you suggest?
No. I'm talking about the value next to it, Fn, which is equal to 1.
Oh, you mean false negative?
Yeah.
Okay.
My question
Again,
is like,
what other value would you suggest?
why this is 1 and it's not 0, and on the bottom line the false positive.
Okay,
Yeah.
so if you look at this, though this is one of these boundaries and there's another decent boundary, so there's 2 boundaries, and for any samples inside this area, it will be classified as class 0. Yeah.
Yeah. Okay.
Okay. So therefore, those 2 samples have been classified correctly by the decision tree. So therefore, here we have true positive 2 equals to 2. And this one is outside this area. This testing sample is located outside this area. So therefore, it will be classified as class 1. And because this sample comes from 0 and has been classified incorrectly as 1, so therefore that's a mistake. Therefore, it makes just the 1 false negative. Because if you look at your decision your classifier, you put this sample into your classifier would say it comes from class 1, but actually it comes from class 0. So therefore, this outcome negative is false. So therefore, we have 1 false negative. Yeah, that's what. If this sample is inside here, let's say it's inside here, okay, this sample is actually inside here, then this will be 0, and that will be 3. Okay, because this outside this area, therefore, yeah, it will be classified incorrectly. Okay, let me ask you another question. If we just change the way we think about this, okay? If I give you, say, this is your classifier, okay, your model, and you have output either 0 class or 1 class, okay, then you put your sample into here. So one is X, another one is Y, yeah? Okay, now if you consider this sample, when you put it into here, what your classifier would tell you in terms of the class label. If you just put this sample, okay, into your model, this is your model, then what your model would say about the class of this input sample is 0 or 1. Have you understood?
No, I don't really get that, to be honest. So we get the class 1, class 0 into a model, and what's the question? What should be what?
Okay, why do we use classifier? We do classification, yeah?
Yeah.
So the output, it can only be either
One of
0
two,
or
yeah,
1.
0, 1.
Yeah, so it's one of these two outcomes. Now you put your testing samples into your model. The testing samples are represented by the coordinates, X and Y. Okay, so if you look at this, 1, so you basically put Y is 1. Okay, X is 0, yeah? No, actually is 0.5.
Yeah.
Oh, sorry. This is why in my lecture, I always give you corresponding tables for regression, for classification, to make you basically clear about what we are talking about, how you can link a data table to a model. Okay, so for this particular sample, testing sample, the coordinates is 0.5 for X and 1 for Y. So here, this value would be 1. This value would be X. You put it into your model. And this model actually is this. So it's going to testify the value of X for this sample to say if it's inside between 1 and 2 or outside, in order to give you the answer in terms of the samples class. So therefore, if you look at this 0.5, this is 1. And this formula is not relevant to 1, so you can ignore 1. Okay, it only relates to X, and X is 0.5. It's beyond this area, yeah, outside this area. So what your model would say? It will say class 1, yeah?
Yeah, if it would predict. Right.
Okay, I'm really, okay, you need to be at this stage. This is some very basic concepts and very simple model. It cannot be even simpler than this.
Yeah.
Okay, so we use this testing sample. And if you look at the coordinates, X 0.5, Y is 1. Okay, so we have two inputs. You give the values into your model, okay? Then your model, what your model will be doing, it will be checking the values against your decision rules. So if the value is not relevant to Y, so you can ignore Y. You only need to consider X. So if X is falling into this area, your model would say class 0. If it's beyond them or outside, your model would say class 1. So therefore, in this case, your model would say class 1. But from which class your model this sample comes from? It comes from 0 class, yeah? And classified as class 1. So therefore, this is a mistake. Therefore, we have this 1 here. Yeah.
Okay.
Yes, I have one question
So this is again, in my lectures since week 1, I always emphasize, don't concentrate on creating some very complicated models. You need to understand some very basic concepts. Don't jump to, oh, I can do deep learning. I can do a convolutional network. It doesn't mean anything unless you have some very basic knowledge about machine learning algorithms. This is since my week 1. I emphasize this always. I emphasized data quality issues, data types since week 1. But still now, if we look at someone's submissions, still some data types are not correct. Okay? So don't jump to something too complicated without understanding some basic concepts. So since knowledge is built up step by step, okay, step by step. So if we want to move further in the future, it's better for you to have some solid knowledge, basic concepts first. Okay, but this is what, if you just look at this basic, very simple decision tree, they represent decision rules, they represent the decision boundaries, then they partition, we talked about decision boundaries, okay? So they partition this space into 3 segments. So 1 is for class 0, the other 2 for class 1. Then depending on where your testing sample falling into this coordination system, then your model would determine what would be the classification results. Okay, so just if you put your model, it just look like this. If you just link to a data table, so you would have X here, you'll have Y here, then here is class. Okay. So in this case, this is a 0.5. This is 1. And your classifier would say is class 1. And actually, this sample comes from class 0. So therefore, this 1 is a mistake. It's false. It's not true. So therefore, this contributes to just 1 false negative. Okay. And also, as I said, when you add these 2 figures together, they should make the total number of testing samples from positive class. So if here you agree with this is 2, then this definitely would have to be 1. It cannot be anything else. Because 2 plus 1 makes 3. And that's the total number of samples from positive class or from class 0. Okay, so you can say 3 class samples from class 0, another 3 from class 1. Yeah, so they always you can have some way to check. Sorry, this looks a bit mess. Okay. Any other questions?
No, just to make it clear. So if you go back to the table, on the first line, on the first row of the data, right?
Yeah.
Go back to the table. Yeah. You take the first class, how many are true and how many are wrong, like false. On the second row, you take the next class, class number 1, right? Is that correct?
So you're talking about those samples, or
yeah, this specific sample. So
okay, let's look at these 2 samples. Yeah.
Yeah.
So these 2 samples in terms of X coordinate is 1.5. Yeah. So this is 1.5. So we would put 1.5 here. And Y is 1. So y is 1. So this sample is inside this area. So your classifier would say 0. Yeah. So similarly, we can do this. This is again 1.5. And this is 2. Yeah, 2. So class 0. And these two samples, they are from class 0. Yeah, because they're black and not black, they're white. And white circles. So they're from class 0. And your model says, yeah, they are from class 0. Then that's true, positive. Okay, the correct classification. So therefore, we have 2 here.
Yeah. So
And similarly, yeah, if someone want to give this table, then that's even better. That basically shows your understanding. You can add another column. Sorry, you can add another column. You can say add a true class or observed class. Okay, you can say true class or observed class. Oh, observed. Yeah, so add them here. If they match, then that's correct classifications. If they don't match, they're either false positive or false negative. Okay. Yeah, we can just check like that.
yeah.
Okay. Okay, good.
Yeah, thank you.
Okay, that's fine. And so I suppose here is okay with this question 4. 3 data types. Okay, if you have done your coursework properly, you shouldn't have any problems with this question. So it's very much relates to your coursework. Okay, you need to give examples in this A. You need to give examples about any variable satisfies both conditions, nominal and binary. And the second one is ordinal and binary. Third, C is interval and discrete. So you need to consider both, not only just one of them. Okay, just give an example, give a value. Ordinal binary, you can say like AM, PM, for example. Yeah. Nominal binary, female, gender, male. Okay. Variable sex. Then those are the values. Okay, so possible values. So we can just work, just do it like that. Our next one is about, we have this data table. Data table. So 6 variables. And their data types, descriptions, and some typical values or value range. Okay. So here it asks you about if we do k-means, what pre-processing we need to carry out. And also you need to explain what. Yeah. So you just, your answers have to be linked to specifically to all these attributes. Okay. So you cannot talk anything in general. So you say, I need to deal with data quality problems. I need to do data integration. I need to do data cleaning. That's too general. So you have to specify in relation to each of those 6 attributes what data pre-processing you would need to consider. Okay, of course, you can put them into certain categories. For example, this is a categorical type, and this is a categorical type. Okay, for categorical type, we have something in common in terms of pre-processing, right? And also, this is a numerical type. So you can put them into the same category, then discuss some common pre-processing. For example, the value ranges for those three category numerical variables, they're very different. So this is very small, and this is very big, right? So we can do normalization and to just change the value range, either use standardize the value range, either use z-score or use range normalization. But categorical, because k-means requires numerical type of data, so we need to do transformation, convert them into a numerical type by using one-hot encoding. Right? And this can be rejected because we normally don't use ID type attributes. Then other things like missing values, so that's applicable for whatever attributes. Outliers, that is applicable to basically any variable. And also k-means is very sensitive to outliers, and also very sensitive to different value ranges, because the k-means uses Euclidean distance for similarity measure. Yeah, I know some of you didn't use k-means in your coursework, okay, but quite a few of you actually use the k-means. So basically, this directly relevant to your coursework. So it cannot just talk anything some too general. Okay, that can be applied to anything, whatever data set, whatever attributes. That's not very, that will be not very good. So just consider all these attributes. Just then talk about what you need to, pre-processing you need to do. Okay, so this is three. Yeah, this question too is just some basic concepts. So it's open, basically open answers. Open answers questions. You can use different ways to really present your answers. See some questions there. Has anyone asked any questions in the chat? No.
Zach,
So.
can I ask a question, please?
Mm.
I just wanted to know, I'm still slightly concerned about in terms of entropy sort of calculations and stuff. Would we be required to go through the whole calculations and stuff like that in the
No.
exam? No. Okay. All right. So the only calculation, the only calculations are the ones that you highlighted. That's it, right?
Yes.
Okay, thank you. That clears a lot of things up. Thank you.
Yes. Thomas. Yeah, Thomas, I have never seen you in my class. Okay, it's good to see you today. Okay, as I said many times in the lectures, we wouldn't publish any answers, marking schemes. This is the university's policy across all these courses modules. It's not only for this module. So, but you can write down your answers send your answers to me. I definitely can have a look then to give you some feedback. Okay. We wouldn't offer any marking schemes for whatever modules. Okay, so that's what would be my answer. Anything else? Okay, it has been recorded. And there's a okay, so I think that's all. Question 1 is very it's multiple choice questions. You need to basically do it very quickly. Ideally, 1 minute or maximum 2 minutes per question. Okay, it's some very basic concepts. If you're very familiar with the content of this module, you wouldn't have any difficulties. But in the exam, remember, don't stick with one question for too long. On average, if you have 4 questions, 2 hours on average, just the maximum 30 minutes per question. Okay, I mean the big question, not the smaller sub questions. Choose something you're more confident first. Okay, because at the beginning, normally, even for myself, when I did the exams many years ago, when I was a student, it just naturally people would become nervous. Even you were well prepared or whatever, it is always natural. That's, I think, a natural response. Yeah, to some events like that. So at the beginning, it's important for you to pick up something you're more confident first. Then gradually you will enter the, exam mode. You will become more confident. Then you just try something at the beginning. It looked seems very difficult, but yeah, maybe afterwards, after 10 minutes, 20 minutes, you would be feel, oh yeah, it's so easy, not that complicated. Right? Another thing is, in the exam, you did the exam before, you don't need to write down the exam questions. You only need to clearly label the question A, Q1, A, B, C, D, and Q2, A, Q2B. You can just not necessarily follow that sequence as long as you clearly labeled. This part is for the answers to which question or sub-question. That is okay. So don't write down the questions. Okay, it's not needed, and it's going to waste your time. Okay, just make sure you just go directly to questions. Okay. Yeah, you did a lot of questions before, but again, I would like to emphasize in the exam, don't talk to each other. If you have any questions, raise your hands to the invigilator. Okay, they will come to you, either myself or the supporting invigilators, then to answer your questions. Okay, yeah.
Sir, can we go over the other question paper quickly?
No,
if you don't
cannot.
mind.
It cannot be quickly. It always takes time. Okay, I would like you do it by yourself. Send your answers to me, because in this lecture and the previous lecture, I talked always myself. I would like to know, how you have understood or what you would like to do. Okay.
Yeah.
I think that would be.
Sorry for interrupting. Just one last question on my side, and I'm going based on the k-means. So it was a question 3 on the pre-processing. So basically, I agree with everything that you said for the unique ID, for the numeric values like normalization and so on. We had 2 categorical values. Yeah, good. So we have 2 categorical values, which is the town ID and the tax. So I agree we can do the tax A, B, C, D, one hot encoding, which adds a couple of new features. But what about the town ID? If you do this and it has 150
that is a good question. Okay.
And I say just make it
something I didn't mention, because normally if you do further research, you would say if a categorical variable has so many distinct values, one hot encoding is not ideal. Okay, we didn't talk about this. So that depends. If the town number has so many different distinct values, we may not consider it a category, just the ID. We would consider it ID type attribute. It has too many values. But in this case, it doesn't say how many different towns, really the town numbers we have. So it's either if it has so many, we would treat it as ID type. So therefore, there's no pre-processing. We even don't need to include this in our analysis. If it's not that many, then we could consider one-hot encoding. And also in practice, we could have actually combined them by regions. Okay, combine them by region, say northeast, southeast, or something like that, to reduce the values for categorical variables. Yeah, that's a good question. Okay, so in other words, if you say this is you do one-hot encoding, I would accept. If you say you treat this as ID type because it may have too many values, then I would also accept. So that depends. Okay.
Yeah, sure. Okay, thank you. And just I think I heard it well, but the three values you do normalization, right? From 0 to 1.
Yeah, you can do normally if you use range normalization, you would do between 0 and 1. And you could also use z-score. Yeah. Either way is okay. Yeah. We just standardize the value range. Yeah. Either use range. If you use range, normally it will be between 0 and 1.
Okay, thanks.
Okay. If you prefer to have another session next week before the exam, I think I can do. Which day is better, Monday or Tuesday? I don't know. I could do maybe next Monday at the same time, 11 to 1. So just pop in if you have any questions. You can pop in then to answer questions, ask the questions. Alternatively, you can send me your answers for some questions which you may not be very sure. Then I can have a look then to give you feedback. Okay. And your coursework marks will be available by Monday next week. Okay, so after that, you can work out how many marks you would need from the exam in order to either pass this module or to be distinction for this module. Okay, so do some simple calculations. Oh, another thing I have forgotten. Don't use exam as an exercise. You need to do your exercise now. Okay, don't try your fortune in the exam. There's no fortune if you're not prepared for. Okay, so think about over last 12 weeks. Yeah, then now if you want to catch up, there are actually quite a lot stuff. Yeah, you have to understand. You have to just to be well prepared. I think that the next a few days before the exam, actually, they are very important. Okay, I would like, I said this, I would like everyone can pass, can score a very high mark. Okay, so don't use the exam as a exercise. It's not an exercise. It can lead to some very, either very brilliant outcome or just some failure. Then someone would have to take a receipt over Easter holiday, or even maybe have to repeat this module next year. Okay. Now you still can control what will be happening to you. So just make your best effort to prepare for the exam. Okay. Essentially, do the exam papers, pass the exam papers. like what we did today. That's very important.
Sir, just a quick question. Are there any more, like, would there be any resources that you would suggest, like, where we can attempt the questions apart from?
No, yeah, no need. I think my slides would be enough.
Okay, okay. And is there any like way, like if there's more questions that we can practice and stuff, or just these two questions
Yeah,
paper would be enough?
yeah, that would be enough.
All right.
Yeah, that
Okay.
would be enough. There are many other papers on my LSB. If you search for past exam papers for this module, yeah, you can find a lot of past papers, but there's no need.
Okay. Thank you so much, sir. And
Okay,
would
you're
you be
welcome.
would you be sending the invite for the Monday session, or would we just join in this channel?
I will remind you. Yeah, just we can just use this link again. Then, yeah, I will remind. I will email everyone to remind you of this of that session.
Thank you
Okay.
so much.
Mm,
This
that's
was
fine.
very helpful. Thank you.
Okay, good to know that. Okay. Okay, enjoy your time. Yeah, you how many exams do you have? Only this one.
Yeah, it's a busy.
Okay, good. Okay, good. Another thing is, if any of you want to change your elective module for the second semester, you need to email me. Okay, email me. I have received a couple of requests. So what I would do later would be I send over all these requests to the course support team. Then they're going to amend your records. Okay, and afterwards the timetabling team will say which module you should be attached to for the next semester, for the second semester. So it's important for you to do, if you want to really change, it's better for you to do it now. Okay, the latest time I think is maybe the first week of the second semester. It's normally most of you either choose AI or choose AI or yeah, AR and VR. I think only a few have chosen internet computing. Yeah, internet computing. Anyway, it's your option. So, but what I would like to know is, if you want to make changes, let me know. Don't delay it. Okay. Otherwise, you wouldn't say your timetables for the module you intend to take. Okay? And also, it takes time for the co-supported team and for the timetabling team to make changes accordingly. So it's better for you to do it now. Okay. Yeah. Okay. Thank
Sir,
you for
sorry,
yeah.
sir. Just a quick question. In terms of the second semester, when is it starting and what days would the classes be?
22nd of January, Monday.
Okay. And what days would be the classes?
Okay. So you're level 6. So your level 6, I think, is
Wednesday and Thursday.
Yeah, Wednesday and Thursday. Wednesday, 3 lectures.
Okay, so it will remain the same. It's not changing.
It's the same. Yeah, it's the same.
Okay.
Yeah,
Thank you
it's the
so
same.
much. Thank
Yeah.
you.
Okay, you're welcome. Okay, thank you for coming. I will see you next week. Bye for now, everyone.
Thank you. Bye.
Bye.